Hello everyone. In this video we're going to be solving a logarithmic equation with base 10. So log x means base 10. I keep saying it because a lot of times people are going to say, hey, you didn't specify the base, but when it's not written, it's usually base 10. And I know some people use it for the natural log, which is weird, but anyways, I call it ln. So since we have log x and I'm going to obviously use log for one of my methods, but I'll be presenting two methods, by the way. Let's start with the first one. So for my first method, I'm going to use substitution. I'm going to go ahead and set this equal to y. And from here, log x becomes y minus 1, right? Okay, so I'm going to find x from here. By using either the definition of logs, because this is base 10, I can safely say that, hey, 10 to the power y minus 1 equals x, or you can do 10 to the power both sides, same thing. So from here I get x equals 10 to the power y minus 1. Awesome. So that is my expression for x, and this is my expression for 1 plus log x. Let's go ahead and do the substitution, but let me rewrite the original problem. X to the power 1 plus log x equals 100. So I'm going to go ahead and replace x with 10 to the power y minus 1, and I'm going to replace 1 plus log x with y. Okay, let's do it. And we get a simple exponential equation. So the goal of using substitution here is to get rid of the log and completely turn it into an exponential equation. But anyways, it's the same type of thing. They can always be converted, right? So now, this is hopefully more familiar than logs. We can go ahead and multiply the exponents. 10 to the power y squared minus y equals 100. But 100 can be written as 10 to the second power. And from here, since the bases are equal, we can safely say that the exponents are equal. So y squared minus 1 equals 2. This is a quadratic equation. Let's go ahead and put everything on the same side. So we get y squared minus y minus 2 is equal to 0. Great. How do you solve this equation? You can use the quadratic formula, or you can use factoring. You could also do completing the square, which is kind of weird. I don't recommend it, but you can also, you can definitely use it too. How does it work? Let me quickly show you, even though that's not the best method here. Maybe we'll just experiment with that. Okay. So you kind of look at the coefficient of y, regardless of the sign, positive or negative, doesn't matter. In this case, it's going to be -1, but 1/2, and half of that number is basically squared. So we're supposed to add 1/4 to both sides. Make sense? And when you add 2 plus 1/4, that is going to turn into 9/4, which is a perfect square, and that's perfect. The left-hand side now becomes y minus 1/2 squared, and now we can basically take square roots and find both solutions. In one case, y minus 1/2 is square root of 9/4, which is the positive square root. That's going to be 3/2. Or we can write the right-hand side as -3/2. Because there are two numbers whose square equals 9/4. So don't get me wrong. I'm not saying the square root of 9/4 can be plus minus 3/2, but more like there are two numbers whose square equals 9/4, and those are 3/2 and -3/2. Make sense? Hopefully it does. Now we can go ahead and add 1/2 to both sides. That's going to give us 4/2, which is 2. And from here we're going to get -2/2, which is -1. So I know it's kind of complicating things, but it's also an important method. Sometimes your teacher may ask you, hey, you have to use what is it called? Completing the square. Okay, you have to complete the square. And it's actually how the quadratic formula can be proven. So that's kind of cool. Anyways, so those are the solutions, y equals 2 and y equals -1, but we don't care about y, we care about x. What is y and x? What's the relationship, right? Well, remember, 1 plus log x equals y, but it's in this case 2. So from here we get log x equals 1. That means x equals 10. Great, so that's one of the x values. Let's go ahead and take a look at the other one. 1 plus log x equals y, and that's -1. If 1 plus log x is -1, that means log x is -2. That means x is equal to 10 to the power -2, which can be written as 1/100. So those are going to be the solutions. That's the end of the first method. Let's go ahead and take a look at the second method. Okay? So for my second method, I'm going to rewrite the original problem all the time. This is the original question. Now, in this case, I'm not going to use substitution because we already used it, but I'm going to log both sides. So let's go ahead and log this and log that. Now, as you know, this is going to move to the front because that's the properties of logs, which is really, really cool. That's going to give us 1 plus log x multiplied by log x equals log 100. But remember, 100 can be written as 10 squared. Again, the 2 can be moved, and log 10 is equal to 1. So it's 2. You can also think about it this way. The number of zeros will give you the answer all the time. So if you have log 1 million, that's going to be 6 automatically, right? Okay, great. So that's log is something that we can use to reduce the size of the numbers because they can take up so much space, but log will just reduce them to the number of pretty much digits, maybe minus 1. Anyway, something like that. So this is 2 because that's log 100. And now we have a quadratic equation again, right? But this time the substitution is slightly different. We're going to call this u. That's u. Okay, so u times 1 plus u equals 2. U plus u squared is equal to 2. And we end up with something very similar. It's not the same equation, obviously, but this equation is easy to solve. Notice that the sum of the coefficients is 2. So 1 is a solution. The other one you can find either by using Vieta's formulas. C over A is the product. So it's negative 2. Or you can just, find it easy, right? It should also be easily found like u minus 1 times u plus 2 is going to give you the factoring. And from here, u equals 1 or u equals negative 2. But u is log x, so this is log x. This implies x is equal to 10, right? Okay, and this is log x as well. And from here, x equals 1 over 100, or you can say 100th. Okay, so there are basically two solutions. Let's go ahead and take a look at the graph and see what this looks like. Okay, great. So the graph we're looking at is y equals x to the power 1 plus log x. And remember, the original problem was this equals 100. Why didn't I show 100? Because that's basically way out of bounds, right? It's not going to fit. Otherwise, the graph is just going to be like a vertical line almost if I zoom out that much. Anyway, so you get the idea. Even though it's not visible, you kind of can visualize it, hopefully. Y equals 100 is a horizontal line that's way above the viewing screen that we're looking at right now. But you get the idea, hopefully. There's going to be two solutions because when this line is intersecting, it's going to intersect at 2 points. You get the idea? And those values are going to be x equals 10 and x equals 100th. And obviously that it kind of indicates a very small value because that's going to be super duper close to 0. And this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you tomorrow with another video. Until then, be safe, take care, and bye-bye.